Right now, beneath every ocean wave you have ever seen, beneath every shipwreck and coral reef and sunlit, shallower world, something extraordinary is happening. 6 miles below the surface of the Pacific Ocean, in a place where the weight of the water above would crush an unprotected human body in an instant, where temperatures hover barely above freezing, where no sunlight has ever touched a single grain of sediment, something is alive. It is moving, feeding, evolving, and thriving. To reach it, you would descend past the point where light vanishes, around 200 meters, and keep falling for another 10,834 meters more. If you placed Mount Everest, the tallest mountain on land, into this trench, its snow-capped summit would still be submerged beneath more than a mile of ocean. This place has a name. Scientists call it the Hadal Zone. Named after Hades, the ancient Greek god of the underworld, it is the deepest, most extreme, most unexplored habitat on the surface of our planet. And yet, it breathes. The ocean is not a single place. It is a series of worlds stacked upon each other, each one darker, colder, and quieter than the last. At the surface, sunlight floods in and life is extravagant, colorful, vast, and hungry. 50 meters down, the warmth fades. 200 meters below the waves, the last threads of light finally dissolve, and you enter the mesopelagic, or twilight zone. Below that lies the midnight zone, and then the vast, cold deserts of the abyssal plains, stretching across roughly 60% of the ocean floor at depths between 3,000 and 6,000 meters. But the deepest trenches go further still. The Hadal Zone officially begins at 6,000 meters, roughly 20,000 feet, and extends to the very bottom of the ocean at 11,034 meters in the Mariana Trench's Challenger Deep. In total, there are 46 distinct Hadal habitats scattered across the world's ocean floors, almost all of them in the Pacific. Combined, they cover an area roughly the size of Australia, yet they account for more than 40% of the ocean's total depth range. These trenches do not form by accident. They are the scars left by the most powerful geological forces on Earth. Deep beneath the ocean floor, tectonic plates are in perpetual, glacially slow collision. Where one plate dives beneath another, a process geologists call subduction, the seafloor is dragged downward, carving long, narrow, V-shaped canyons that sink miles deeper than anything around them. The Mariana Trench, the deepest, was formed this way, where the enormous Pacific Plate is slowly subducting beneath the smaller Mariana Plate. Earthquakes rattle the walls. Occasional volcanic activity shapes the sediment. The trench continues to deepen, millimeter by millimeter, across geological time. Imagine a crack in the floor of an already impossibly deep ocean. A crack so deep and so dark that it feels less like a geographical feature and more like a doorway to another world. At its floor, the pressure reaches approximately 15,000 pounds per square inch, more than 1,000 times the pressure at the surface. For context, every 10 meters of depth adds 1 additional atmosphere of pressure, equivalent to the weight of the entire atmosphere pressing on every inch of your body. At Challenger Deep, that accumulates to roughly 1,100 atmospheres. Temperatures hover between 1 and 4 degrees Celsius, just above freezing. There is no photosynthesis because there is no light. The only food comes from above, the slow, perpetual drizzle of organic material sinking from the sunlit surface thousands of meters overhead. Dead plankton, fish, whale carcasses, even debris from human civilization. And yet, in this crushing cold and absolute dark, evolution found a way. Science once believed the deep ocean was essentially dead. The Victorian naturalist Edward Forbes, working in the mid-1800s, proposed that the ocean below 600 meters was an azoic zone, a lifeless void. The notion was elegant and wrong. The first systematic evidence that life thrived in the Hadal zone came in the early 1950s, when both the Danish Galathea II expedition and the Soviet Vityaz vessel independently discovered that at depths of 6,000 to 7,000 meters, the character of life changed dramatically, distinct from anything in the abyssal zone above. The Hadal zone was recognized as its own biological world. Today, scientists have documented a remarkable diversity of creatures here. Sea cucumbers lumber across the sediment floor. Polychaete bristleworms burrow into the soft mud. Bivalves, isopods, sea anemones, and copperpods have all been found. Xenophyrophores, single-celled organisms that can grow to the size of a dinner plate, form alien geometries in the sediment. But the two creatures that have come to define the Hadal zone in the public imagination are the amphipod and the snailfish, and both are stranger than fiction. Amphipods are crustaceans, distant relatives of shrimp and pillbugs. In shallower waters, they are modest, unremarkable creatures a few millimeters long. In the Hadal zone, they become something else entirely. Species like Hirandelia gigas, the Mariana Trench's dominant scavenger, have become so well adapted to depth that in some respects they perform better under extreme pressure than at sea level. Their enzymes work more efficiently under crushing conditions. Their cell membranes are laced with specialized unsaturated fatty acids that keep them flexible rather than stiff in the cold. Most remarkably, Hirandelia gigas has evolved a unique cellulase enzyme, an enzyme capable of breaking down cellulose. Researchers studying the Mariana amphipod found that it can digest plant material, wood debris, coconut husks, bamboo fragments that sinks from distant coastlines and drifts into the trench. In one of the harshest environments on Earth, evolution invented a way to eat the trees. At shallower reaches of the Hadal zone, around 6,000 meters, a different kind of amphipod appears, the supergiant. Alicella gigantea can grow to more than 28 centimeters, nearly a foot long. Photographed at a depth of 5,300 meters in the Pacific, they are among the largest amphipods ever recorded. Specimens retrieved from the 10,047-meter deep Kermadec Trench were estimated at 34 centimeters. They are ghosts of the deep, pale and enormous, arriving in swarms at any sizable carcass, feeding for hours, undisturbed by competition. If the amphipod is the Hadal zone's patient scavenger, the snailfish is its apex predator and the deepest living vertebrate on Earth. Species like Pseudoliparis belliaevi and the Mariana snailfish, belonging to the family Liparidae, have been recorded at depths greater than 8,000 meters. They are, by any surface standard, absurdly fragile looking. Their bodies are pale, almost translucent, with soft gelatinous flesh and no scales. They have no swim bladder. That gas-filled organ that helps most fish achieve buoyancy would be catastrophically compressed at this depth. Instead, they maintain neutral buoyancy through lipids and reduced bone density. But look closer, and their adaptations become breathtaking. Their proteins are stabilized by high concentrations of a compound called trimethylamine N-oxide, or TMAO, which prevents cellular structures from deforming under crushing pressure. The deeper a fish lives in the Hadal zone, the more TMAO it produces, a biological pressure suit built molecule by molecule. Their jaws are designed for one prey, amphipods. They have a secondary set of pharyngeal jaws deep in the throat, a kind of internal trap, allowing them to seize and swallow crustaceans in the absolute dark. And they likely live fast and die young, their lifespans compressed by the high disturbance environment of these tectonically active trenches. When Victor Vescovo descended to the Challenger Deep in his submersible Limiting Factor on April 28, 2019, reaching a world record depth of 10,928 meters, he filmed new species of amphipods at the very bottom and observed what appeared to be a previously unknown species of stalked ascidian drifting near the trench wall, its form unlike anything catalogued before. The expedition, The 5 Deeps expedition, the first to send a human to the deepest point of all 5 of Earth's major ocean basins, confirmed what scientists had been slowly realizing for decades. The Hadal Zone is not a wasteland. It is one of the most biologically distinctive habitats on the planet. Consider for a moment what it is like to be hungry at the bottom of the world. Food is not guaranteed here. The Hadal Zone is, in metabolic terms, a desert. The organic marine snow that drifts from the surface, plankton fragments, fecal pellets, dead cells, loses much of its nutritional value by the time it sinks 7 miles. Meals can be weeks apart. And then, a whale dies. Somewhere in the productive surface waters, a sperm whale, perhaps 40 tons, draws its last breath and begins the long descent. As it sinks, its carcass passes through each zone of the ocean, feeding different communities at different depths. By the time it reaches the Hadal floor, a journey that can take days, it carries an enormous concentration of high-quality fatty acids and proteins. In the language of the deep, it is a city's worth of food arriving at once. What happens next is the Hadal Zone's version of a feast. Chemical signals, dissolved compounds leaching from the carcass, drift with the faint thermohaline currents that flow through the trench. The amphipods sense them first. Hirandelia gigas, despite living in near freezing darkness, is fast, capable of locating a food source from remarkable distances in pitch black. They arrive in swarms of thousands, their translucent bodies pressing against the carcass, their enzymes dissolving flesh. The sediment around the whale becomes momentarily rich, its normally sparse microbial community exploding in diversity and density. Snailfish follow the amphipods. They circle the edge of the feast, darting in and withdrawing, picking off individual crustaceans. Polychaete worms emerge from the sediment. Isopods trudge in from across the trench floor. For a brief window of biological time, perhaps weeks, perhaps months, the carcass becomes a Hadal oasis, increasing local biodiversity in ways researchers are only beginning to understand. The 2025 discovery, published in Nature, was even more dramatic than this. Scientists using China's advanced manned submersible, Fenduzi, surveyed a region spanning 2,500 kilometers across the Kuril-Kamchatka and Western Aleutian trenches, at depths between 5,800 and 9,533 meters. What they found rewrote the rulebook. There, clustered around chemical seeps on the trench floor, vents releasing hydrogen and methane from below, were thriving communities of organisms practicing chemosynthesis, not dependent on the sun, not waiting for whale carcasses, using the chemical energy of the earth itself to build life. Thousands of worms and mollusks at nearly 10 kilometers depth. Ecosystems powered not by a distant star, but by the planet's own interior. This discovery, say the researchers, suggests that chemosynthetic Hadal communities may be far more widespread than previously imagined, possibly existing in trenches across the globe, representing an entire biological network that existed for millions of years before we knew to look for it. The Hadal Zone holds lessons that extend far beyond marine biology. The biology of creatures adapted to extreme pressure may, according to researchers at NOAA, hold genuine promise for medicine. The molecular mechanisms that stabilize proteins under crushing pressure, particularly the role of TMAO, are currently being studied in the context of diseases like Alzheimer's, where protein misfolding is a central feature. The Hadal Zone, in this light, becomes not just a curiosity of nature, but a potential pharmaceutical library, sealed in darkness for millions of years. The carbon implications are equally profound. Trenches act as funnels, capturing organic matter from vast areas of ocean surface and concentrating it at depth. This means the Hadal Zone may play a significant, currently underestimated role in the global carbon cycle, sequestering organic carbon at extreme depth and locking it out of the atmosphere. As climate scientists refine their models, the Hadal Zone may emerge as a variable of quiet importance. And yet, despite all of this, Despite its remoteness, its depth, its crushing inhospitality, the Hadal Zone is not beyond humanity's reach in the ways that matter most. A study published in Royal Society Open Science in 2019 examined amphipods from 6 deep ocean trenches across the Pacific, from the Japan Trench to Challenger Deep, and found that over 72% of individuals contained at least one microplastic particle. At Challenger Deep, the deepest point on Earth, every single specimen examined contained synthetic material: nylon, polyethylene, polyvinyl alcohol. Microplastics in the Mariana Trench sediment have been found at concentrations of up to 2,200 pieces per liter. A new species of amphipod discovered in the Mariana Trench, named Eurythanes plasticus in 2020 by researchers at Newcastle University, was found to contain plastic in its body before it had even been formally described to science. A creature unknown to humanity, already contaminated by it. When Victor Vescovo descended to the record depths of Challenger Deep in 2019, he observed what he described as cloth or plastic near the ocean floor. Even there, at the absolute bottom of the world, a sea cucumber was resting on what appeared to be human refuse. He called it, quietly, a gut kick. The Hadal Zone endures these intrusions. Life, as it has done for hundreds of millions of years, continues to adapt. The snailfish keeps gliding. The amphipods keep feeding. The trench floor holds its ancient, cold silence, regardless of what drifts down from above. There is something humbling about the Hadal Zone that goes beyond the statistics, beyond the numbers of pressure and depth and temperature. It is this: life did not need the sun to exist. In the deepest trenches, organisms evolved to run on chemical energy, on pressure, on cold and darkness, centuries before the first human ever looked up at the stars and wondered if life could exist somewhere else. The Hadal Zone suggests that life is not a fragile accident dependent on perfect conditions. It is a stubborn, inventive, borderless process that fills every possible niche, no matter how extreme. The scientists at Woods Hole Oceanographic Institution, who collaborate with NASA's Jet Propulsion Laboratory on deep-sea exploration technology, do not find the parallel accidental. If life can thrive at 11,000 meters depth under 1,100 atmospheres of crushing pressure in permanent cold darkness, then the subsurface oceans of Europa, Jupiter's ice-covered moon, or Enceladus, Saturn's geologically active satellite, begin to look less like science fiction and more like reasonable hypotheses. The Hadal Zone may be the closest thing on Earth to an alien ocean. And it is right here, beneath our feet, beneath our ships, beneath everything we know. The snailfish drifts past the camera one more time, pale, soft, ancient in its design. And then the darkness swallows it whole. It does not need the light. It never did.